I'm Eric Hovland here at the Florida Aquarium, and we're going to meet Sela today. Let me bring Sela right on over. Sela is our young giant Pacific octopus. Sela is named for the infamous Greek monster that used to terrify the sailors, but I like to think of her as the Greek goddess, the nymph that she once was. Because what a goddess would have, a big heart, especially as we're talking about hearts this month. And not just one heart, but two to spare. It takes a true Greek goddess to have 3 hearts. So 2 hearts just keep the blood moving throughout these long suckered arms. Very strong arms, I might add. And then 1 heart keeps the blood moving around the circulatory system and around all the organs which are located up inside her body, which looks like her head, but it's called the mantle, this big bag of octopus guts right up here. Look at that right there. That's the siphon that's squirting out the water. That's how you can see squids, their relatives, octopuses jet across the water and move so rapidly. Now, octopuses have very strong hearts, but it takes a lot of effort to jet propel, so you'll often see them crawling along the bottom. Their heart beats about half as much as ours does, but you know what? There's something else that's very royal about this Greek goddess, and that is her blood. It is a royal blue. That's because it is different than our blood. Our blood is iron-based and red, and in octopuses, they have a copper-based blood. Therefore, it's hemocyan, and that's named for copper or cyan, the blue color. Oh, right in here, by the way, too, is the beak. So a beak, just like on a parrot, but in this case, it's used to pull crabs, one of their favorite foods, apart, or shrimp, or lobsters, or even the fish and different things that we feed Sela right here. And again, that all takes 3 strong hearts to keep all these arms in action, where the blood is clearly circulating, probably better than mine right now. This is Sela. She's no monster. She is a real Greek goddess. And a strong one at that. It's gonna be fun explaining all of these arm hickeys. And let's get to know a whole corral of horseshoe crabs. You know what? Here's a little something you need to know about horseshoe crabs. They're not really crabs. In fact, their closest relatives are spiders. I am not a big fan of spiders. But this is not a spider. This is not a spider. This is not a spider. No, this is a horseshoe crab. But check out all those limbs. It does resemble a spider right up to the mandibles in the front, I should say the fangs, the chelicerae, that they can use to grab and chew up their prey. And then even the bases of their arms right here help them pick up food from the bottom, like worms and little hard-shelled animals, and bring them up and gnash them more or less between their knees and bring them up into their mouth. The horseshoe crabs have very special properties to their blood, which first of all is blue. It's copper-based. It's called hemocyan. So again, that blue blood works better in the environments where the horseshoe crabs live. And those environments might be low in oxygen and that water might be cold. So that's a good combination. That works really well for them. And their body is a very simple circulatory system. The blood more or less floods the internal limbs and the body. That simple heart just pushes it in and out of the legs and the limbs, and that's how it works. So we've been able to isolate properties from that blood in the lab environment that help us test medications, that help us have healthier lives as a result of the good old horseshoe crab. And the hearts we're going to talk about today are in the sea stars. We got a whole load of sea stars in here. Now this water is cold, and these sea stars are really big. They're the kind of sea stars you would see in tide pools up in, say, Oregon or Washington or all the way up to Alaska. In fact, where our friend Sela, the giant octopus, lives too. So let's find out something about sea stars that I think is really exciting and unique. They have built-in pumps. So there's a little intake right there, that little circle that every sea star has, and it acts as a water intake and a filter, and it's called the madreporite. And he's using the water vascular system. water gets pulled in through here. They have a big round stomach called a cardiac stomach that can also create a pumping action and pull that water right through the tube feet. And if you look at this sea star over here, you can see all those little tiny tube feet going to work. They're sticking to the wall. They use them to get right in here and open up these clams that were once full of delicious clam meat. They just pull that right open with that powerful pump, and then their stomach comes out and goes right inside the clam. So instead of putting the clam inside, the stomach comes right to the dinner, in that case, tasty clam. And again, just to show you the strength, all these rocks hanging right onto those little tube feet there. So we're going to talk about the heart of a sea star, but they don't specifically have a heart. But they do have a similar system of getting nutrients out to their legs, out to their tissues, and also circulating oxygenated water. And it's again through that water vascular system. That system of pumps pulling in water here, circulating it all throughout a radial canal that's inside the sea star, just in the same respect that blood works in our bodies to get nutrients to all of our tissues. Did I mention that water's